Okay, so we're talking about two important theorems. Now there's a rule in calculus, and the rule is if it has its own name, it's important. It's flashcard worthy. So today we get two of them. It's actually one theorem. So Rolle, Michel Rolle, French guy, came up with Rolle's theorem, which then got expanded into the mean value theorem. So they're kind of the same thing. You'll understand what I mean when they get to it. When we get to it, I should say. Okay? So we'll start with Michel. We're going to learn Rolle's theorem. I forgot about this. We're going to do mean value theorem, and you should be able to count to 10 in German. Yes?
Oh, yes.
Good start. Ein.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Close enough. You kind of mumbled there at the end. 1, 2, 3, 4, 5,
5, 6, 7, 8,
7, 8, 9, 10. 10. Ja, sehr gut. Ja. Ja, was ist los?
Guten Tag.
Ich habe keine Ahnung. Sie? Sie?
Ja.
Yeah. Let's move on. Rolle's theorem. So there is an easy way to remember this theorem, which conveniently is based off of the name of the person that came up with the theorem. What are the odds of that? So, before we get into the fancy schmancy calc talk, let me give you a simplification of Rolle's theorem. You start with level ground. You're going to start right here. And we have a hill. And then we're going to end over here. So the theorem says this. If I roll a ball, see what I'm doing with that? If I roll a ball up a hill and then back down the hill to the same level ground, somewhere along the line I have to hit a peak. Does that make sense? In fact, it's almost so simple, right? If I roll a ball up a hill and then back down the hill to the same level that I start at, somewhere along the line I've got to at least hit one maximum. I could hit a bunch, but at least one. Good? Now, how do we change it? Well, for one way we could do it is instead of rolling it up a hill, we could roll it down into a valley. Similar concept though. If I roll it down into a valley and then back up to level ground, at some point I have to hit a minimum. Okay? So you see what I did with that? We're rolling it because it's Rolle's theorem. Did you just get that?
Yeah.
That's good. That's okay. I knew you'd get there eventually. All right, so now let's do the fancy schmancy calculus speak and what this guy Michel Rolle said. Get rid of my super cool picture, and we'll break this definition down. Okay. First of all, the function has to be continuous. Okay, you can't roll it up a hill and all of a sudden part of the hill disappearing. You're not rolling it over the top of a volcano, you're rolling it up a hill. And then this statement that says f of a has to equal f of b. If a and b are our endpoints, they have to have the same value. A lot of times that value is going to be 0, but it might not be. You might be starting at 1 and 1, or starting at a y value of 7 and 7. As long as they're the same value, you're good to go. And then he said, okay, if this is true, if I've met all those conditions, all of this fun stuff over here, then that's got to be true at least one spot. The derivative of the function has to be equal to 0. In other words, we have a max or a min. Make sense? Good. And I don't know if you need the English because we've already done it. Start at the same y value, go up or down, you're going to have a maximum or a minimum. So let's take a look. We got a little parabola. Eric, what can you tell me about that parabola?
It's a regular parabola.
opposed to an irregular parabola?
I mean, it's a, I don't know actually.
Does it open up or down?
Opens up.
Up. So will it have a max or a min?
And
A min, correct. Doesn't matter, we'll get there eventually. So the first things first, Eric, is that function continuous?
yes.
How do you know?
Because it goes on forever. Wait,
That doesn't make it continuous.
my brain is not working.
And so that matters to me, why?
It is continuous because it's differentiable.
How do you know it's differentiable? Don't tell me because it's continuous. You have to fight. Hafiz, help him out. How do you know it's continuous?
It's polynomial.
Beautiful. It's a polynomial. So that takes care of the first part of Michelle's idea. It's continuous. Second part. Does it start and stop at the same level ground? Okay. Well, the problem has an interval. How did that happen? It disappeared. Well, that's weird. Anyways, please tell me what f of 1 and f of 2 are, please. Please tell me what f of 1 and f of 2 are, please. That makes no sense. I said please twice. Just calculate those values. You probably don't need your calculators.
Sorry. Sorry, I don't know if I said this, but so is that enough time for me to be on the notes to fold these?
We'll talk about that towards the end.
Okay.
It's a pretty sizable chunk, but we'll see what we can do about it.
Okay.
Don't be bashful. Just shout out some answers for me so I can move on. 0
0 and 0.
and 0. Beautiful. So now Michelle is very happy because we've satisfied the continuous part, and f of A is equal to f of B. We're starting and stopping on the same level ground, which means that somewhere in that interval between 1 and 2, the derivative has to be equal to 0. So let's find that point. Take the derivative. F prime of x is equal to 2x minus 3. And set it equal to 0. So x is equal to, as my grandfather would say, 2 turds.
Yeah.
What is it?
What are they doing?
Oh, I don't know. Would it be 3 halves?
Yeah, it would be.
Oh, I'm not real good with numbers. Sorry. That makes me happy. 2/3 didn't make me happy. Why? Other than the fact that it's bad math. Why would 2/3 be a bad thing?
It's not between 1 and 2.
Beautiful. It's not in the interval. It's not between 1 and 2. 3 halves, better answer? Yes. More gooder math, and it's in the interval between 1 and 2. Okay, so it confirms Rolle's theorem. Somewhere between 1 and 2, it's got to get a max or a min. Now, because we know what that parabola looks like, we know that that would be a minimum, because the parabola opens up. Eventually, we're going to get to some functions where we're not going to know what the what the function looks like. We're going to have to come up with some way to determine if that's a relative max or a relative min. Okay, but that's coming soon. Questions on Rolle's theorem? This is a big part of Rolle's theorem. Okay. Now, we move on to the mean value theorem. So before I move on to the mean value theorem, it is crucial that I confirm you understand Rolle's theorem. Because if you understand Rolle's theorem, this is ridiculously easy. If you don't, this is going to make your head melt, or your brain melt, or whatever melts. We're good? Beautiful. So the only thing the mean value theorem does is it takes Rolle's picture and it tilts it. And I'll show you what I mean in a second. Okay, so continuous and differentiable on the interval, similar to Rolle's, but we're not necessarily looking for maxes and mins. We're looking for that gunk. What? Okay, let me explain. For us, we're going to use this. You know what that is, right? Tell me just so I know. Oh my. What, no, not what's the value. What does f prime of c mean? Thank you. Good, okay. Yeah, keeping it simple here.
I thought you were looking for a number.
I don't know how you would give me a, well, you could have made something up.
Yeah.
Just shout it out like 7. See if I just shut up then and move on. Hey, does that look familiar at all? All right.
Is it the slope?
It is a slope. Excellent. If we've got points A and B, then f of A is the y value at A, and f of B is the y value at B. So that's y2 minus y1 over x2 minus x1. This is commonly referred to as the slope from algebra. Algebra, I can't spell. That's why I went into math. This is the slope from calculus. And the mean value theorem says that somewhere in that chunk of festivities between A and B, those two things have to be equal, which still might not make any sense. But when I show you a picture, I think it will make perfect sense. Why is this bottom part here? For some reason, people like to put it in that form, which is the only difference is you just multiply both sides by b minus a. I don't, whatever. I like the top part better. Slope from calculus equals the slope from algebra. There's our picture. So if I take some parabola with 2 points, A and B, if I connect points A and B, I have a secant line. We've talked about that before. The slope of that secant line, I developed an accent there. The slope of that secant line there is found by doing y2 minus y1 over x2 minus x1. The slope of the other line is found by doing calculus. Just looking at the picture, what seems to be true about the two red lines? They are parallel, meaning they have the same slope. Same slope. Slope from calculus equals slope from algebra. Yay! If I take this picture and I spin it, it all of a sudden becomes Rolle's theorem. But we're not going to be able to spin it. We're going to have to do the calculations the hard way. Oh, shut up. Easy peasy. All right, so let's do that. Parabola. So we'll start easy here. Got a parabola. It opens up. But again, that doesn't matter. Slope from algebra equals slope from calculus. Split the screen in half. We'll start with slope from algebra over here. Slope from algebra. F of 2, F of 7. Calculate those two values for me, please. I'll wait. Anytime now, just shout them out. Those values for f of 2 and f of 7, if you just want to, you don't have to raise your hand, just holler them out. Just, anytime you're ready, just go ahead and throw those out for the rest of us.
87.
Right, don't keep it to yourself. What's 87?
12 and 87.
12 is f of 2?
Yep.
87 is for f of 7?
Yes.
Are you sure?
Yes.
I'm so sorry.
I didn't even have to do the work.
Yeah, I just knew it.
I did mental math.
I have to rethink posting those. Fine, I'll just do the work. I feel like a performing circus chimp now. check my work and see if I got it right.
Yeah.
Okay. Check my work, see if I get it. Check my work to see if I got it right. Yeah, I did. Okay. All of a sudden, I hate this class. No, you're not. F prime of x is equal to 10x minus 30. Did that okay? Mean value theorem says slope from algebra has to equal slope from calculus. 15 is equal to 10x minus 30, so x is equal to 4.5. How'd I do? Yeah. Smart fella.
Where'd you get this from?
Magic. Okay. Now, there's two parts to this. One is knowing how to do it, and number two is understanding what I just did. What is this? What is the significance of that x value? My guess is you have no clue. On that graph, where is x equals 4.5? Now, this function is different than the other one, but just in general, what point did I just find on that graph? With me moving monkey. Dexter?
An x-intercept?
No.
Oh, did you find one and then that's
No.
Oh.
I just found that point.
Yeah,
That's the point on the graph where the tangent line, slope of the tangent line matches the slope of the secant line. It's where the slope from calculus matches the slope from algebra. What I neglected to mention over here, I forgot to ask the two questions. Is that function continuous? Yeah, it's parabola. Is it differentiable? Yes, because it's parabola. Great. Okay, move on. And then we did the work. Okay? It's not a max or a min. That's a different calculation. This is the place where the endpoints of the interval, their slope matches the slope of the tangent line. Okay?
Oh.
Oh yeah, there's all the work. Yeah. Look at that. Oh, I get it right. God, I'm so smart.
You should be like a math teacher.
I should be. No. Did I do all the work for this one too, Faith?
No.
I didn't. Woo-hoo. Okay, good. All right. Emma, is that function continuous?
Yeah.
Emma? It is not. Don't listen to her. She knows what she's talking about. So are we done? I mean, if it's not continuous, aren't we just done? Because the rule from mean value theorem says the function has to be continuous and differentiable. That function is not continuous. It's discontinuous at x equals 0. But I can keep going. Why, Luke?
Because it's continuous everywhere else.
Close enough, yeah. It's continuous in the interval that we're talking about. From 1 to 4, we're good to go. Which means I can go through this process all over again. So here is my slope from algebra. Here's my slope from calculus. Let us commence. F of 4 is 4. F of 1 is 1. F 4 over 1 is 1. Did I do that right? Okay. And then the derivative, ooh, let's see, that would be 5 minus 4x to the negative 1. So the derivative would be 4x to the negative 2, which would make 4 over x squared equal 1. So x is equal to plus or minus 2. That was a tribute to Michelle Rolle. Any problems? The answer is yes, there's a problem. What's the problem, Luke?
Negative 2 is in the interval.
Correct. So, negative 2 goes away, and we just get x equals 2. Has to be in the interval. Because in order to get to negative 2, we've got to go over some stuff where ickiness happens. That's a technical term. Where x equals 0, which makes the function undefined. So we only want values inside that interval. Okay, so what does that mean? That means I took this point here at 1. I took this point at 4. I connected them. And then I did some calculus and found the spot where that tangent line comes in so that it's parallel to the secant line. Secant line parallel to tangent line. Slope from algebra equals slope from calculus. Okay? Questions? I know it's a lot today, I apologize. But we couldn't fall further behind. Wait, I did do the work, Faith. I could have just clicked. You know how hard it was to do all that work? I don't have that kind of energy, I'm old.
I didn't know you tricked me. It was on the second side.
I wasn't meaning to trick. I just said, did I do the work? And you said, no, go ahead, performing circus Chip. Get up there and do all the work. All I had to do is this. Look at it. That's beautiful work. Look at that. I didn't get it right, though. That's a feel good right there. Yeah, well, I even included the note there. Darn it. That's it, I'm done. By the way, this is a bridge in, I believe it's in Taiwan, where they decided it would be cool to put the mean value theorem on the bridge. I don't know. I know, you're jealous, right? Wouldn't you like a bridge with the mean value theorem on it?
It's probably easier to memorize. No, you would never be able to escape it.
You guys make it sound like it's the plague. Like every time you drive under the bridge, you throw up a little bit in your mouth.
That's probably what
Just going to work today. Oh, God, again. Coming up. Oh, sorry. Is it on the other side? Oh, it's on the other side, too. Oh, no, it's a different, it's a different formula on the other side. E, F equals, I don't know what's on the other side. Yes, you had it. Okay, done. We're done.
Once I'm done. Now I'll make sure.